Hi students, before starting with the problem, first you should know certain rules. That means you should follow certain steps to calculate the mole fraction of a substance. Okay. So first is to calculate the number of moles of the solute. How to calculate the number of moles of the solute? From the weight of the solute and molecular mass of the solute. Only if you know the weight of the solute and molecular mass, it's possible to calculate the number of moles of the solute. How to calculate number of the molecular mass of the solute? From the atomic mass of the substance. Okay. For example, if it is H2O, if you know the atomic mass of hydrogen and if you know the atomic mass of oxygen, it's possible to calculate. Okay. So hydrogen is 1, but we are having 2 hydrogen atoms, so 2, and oxygen, it is atomic mass is 16, so it's 18. The molecular mass of water is 18. Like this you should calculate the molecular mass. So if you know these two values, you can calculate the number of moles of the solute. Next step is you should calculate the number of moles of the solvent. The same method you should follow. Here the number of moles of the solvent is W1 by M1. W1 is weight of the solvent and M1 is molecular mass of the solvent. Okay. The third step is next you can calculate the mole fraction. If you know the number of moles of the solute and number of moles of the solvent, it is possible to calculate the mole fraction of the solute. Okay. So mole fraction of the solute is represented by X2, that's equal to N2 divided by N2 plus N1. So N2 is number of moles of the solute and N1 is number of moles of the solvent. So N2 divided by N2 plus N1 will give the mole fraction of the solute. Next step is you can calculate the mole fraction of the solvent. How to calculate the mole fraction of the solvent? Same methodology, but here in the numerator you should substitute the number of moles of the solvent. Okay, number of moles of the solvent divided by the sum of number of moles of solute and number of moles of the solvent. Okay, and the next one you should know. See, this is X is nothing but it is the mole fraction of the solution. How to calculate the mole fraction of the solution? From the mole fraction of the solvent and mole fraction of the solute. See, if you add the mole fraction of the solvent and mole fraction of the solute, then it will be 1. Okay, it should come. So this is the rule. So X is equal to X1 plus X2, that is mole fraction of the solvent plus mole fraction of the solute. This will be equal to 1. Okay, right. We shall see the problems now. Read the first problem, students. Calculate the mole fraction of water in a mixture of 106 grams of acetic acid, 10 grams of water and 94 grams of ethyl alcohol. See, these type of problems, actually here 3 compounds are given: acetic acid, water and ethyl alcohol. See here the same procedure you should follow for all the compounds. So it's better to draw a tabular column and do the calculation. It will be easy. Okay. So I have already drawn the tabular column here. So first column I have taken the substance, second mass, then molecular mass and then number of moles. So now let us substitute all the values here, then it would be easy, right? Water. What is the mass of water given? 10 grams. Okay. So let us write 10 here. What is the molecular mass of water? Already we have calculated, right? I have shown you by summing up the atomic mass of hydrogen and oxygen, it's possible to calculate the molecular mass. So it's 18. Okay, molecular mass of water is 18. How to calculate number of moles of water? See, let us take N1 is equal to mass of water divided by molecular mass, so that it is 0.555. Okay. So this is the value, right? So now acetic acid, what's the mass of acetic acid? It is 106. Okay, it is 106. The molecular mass calculated is 60. So how to calculate the number of moles of acetic acid? 106, right? 106 divided by 60. So it is 1.766. Okay. Next, for ethyl alcohol, what's the value given for the weight? It is 94. Okay. Here the molecular mass is 46. So N3, that is number of moles of ethyl alcohol, is 94 divided by 46. Okay. So it is 2.043. Right. Now we can calculate the mole fraction of water. How to calculate the mole fraction of water? Mole fraction of water is, let us take as W, right? It's equal to number of moles of water divided by the sum of number of moles of water plus number of moles of acetic acid plus number of moles of ethyl alcohol. You should sum up everything. Okay. Now substitute all the values. 0.555 divided by 0.555 plus what's the next value? 1.766 plus 2.042. Okay. So now find out the answer. So it is 0.555 divided by 4.364. So the answer is 0.127. So this is, we'll read the problem, students. The mole fraction of benzene in a solution of toluene is 0.35. Calculate the percentage, weight percentage of benzene in the solution. See, in the problem it is given mole fraction of the benzene is given, that is 0.35, and they are asking you to calculate the weight percentage of benzene. So mole fraction of benzene is 0.35, and they are asking you to calculate the mass percentage of benzene. Mass percentage of benzene. How to calculate the mass percentage of benzene? From the formula, that is weight of benzene that is W1 divided by, weight of benzene is W2, okay, divided by weight of solution. Weight of solution into 100. Okay. What is weight of solution? We'll take it as W. But we do not know the weight of benzene and weight of solution also. That we should calculate. How to calculate the weight of benzene? See, weight of benzene. Let us calculate weight of benzene like this. Weight of benzene. See, already we know. See, the mole fraction of benzene is 0.35. So, normally 1 mole of benzene contains 78 grams of benzene. Okay, 1 mole of benzene contains 78 grams of benzene. From where do you get this 78 grams? See, it's nothing but the molecular mass of benzene. 1 mole of benzene contains 78 grams of benzene. Therefore, 0.35 moles, here 0.35, right? 0.35 moles of benzene contains how much? How much grams of benzene? So 78 into 0.35. Okay, that is equal to 27.3 grams. So we know what W2, we have calculated W2. Next we want to calculate the weight of the solution. See, we know only the weight of the solute. We do not know the weight of the solvent, that is toluene. So that should be calculated in the same procedure. By following the same procedure, we are going to calculate the weight of the toluene also. Only then it is possible to calculate the weight of the solution. Okay, we should know the weight of the solute and solvent. See, if we know the mole fraction of the solvent and the mole fraction of the solute, it is possible to calculate the mole fraction of the solution. So like if you want to calculate this solution, it is necessary you want to calculate the weight of the toluene also. So the same procedure we are going to follow. How to calculate? See, this is equal to, already we know in the first step I have informed that mole fraction of the solution will be always equal to 1. Okay, so the sum of these two will be equal to 1, that is x1 plus x2 will be equal to 1. So we are going to follow the same principle, right? So x1 is, we don't know, right? X1 we don't know, x2 we know, that is, this is x2. Okay, so 0.35, okay, plus plus x1 is equal to 1. So x1 is equal to 1 minus 0.35. So what is the value? It is 0.65. So already we know. So 0.65 moles of toluene is there. So we should follow the same. Here 1 mole of toluene contains, okay, 1 mole of toluene contains 92 grams of toluene. Okay, so therefore 0.65, here we have found out, is it not, mole fraction of toluene. So 0.65 moles of toluene contains how much amount of toluene? So 92 into 0.65, that is equal to 59.8 grams. Okay, 8 grams. So this is, what is this? W1. So this is W1, this is W2. Okay, now we know W1 and W2. Now we are supposed to calculate the weight of the solution. How to calculate the weight of the solution? Weight of solution. Weight of solution is equal to W1 plus W2. Okay, W1 plus W2, that's equal to 59.8 plus 27.3, that's equal to 87.1 grams. So we know both the values now. Weight of benzene also we know, and then weight of the solution also we know. Now we are going to calculate the mass percentage. Okay, so we should calculate the mass percentage. Mass percentage of benzene is equal to weight of benzene. What is weight of benzene? It is 27.3 divided by weight of solution. What is weight of solution? 87.1 into 100. Understood? So what is the answer? It is 33.7. Okay, this is the answer. This is how. Read the next problem, students. Calculate the mole fraction of solute in its 3 molar aqueous solution. You are asked to calculate the mole fraction of the solute. We don't know what the solute is, and in general, okay. So given is molality of the solution is given. Molality. Okay, molality is 3 molal, and you are asked to calculate the mole fraction of the solute. Okay, you are asked to calculate. Now how to find out? So molality of solution is equal to 3 molal. That means 3 moles of the solute is present in 1 kilogram. Is it not? 1 kilogram of solvents. So actually what is molality? It is nothing but the number of moles of solute in 1 kilogram of the solvent. Okay, so this is how. So 3 moles of the solute is present in 1 kilogram of the solvent. Now we know the number of moles of the solute. Okay, number of moles of the solute is 3. Is it not? 3 moles. Number of moles is 3 moles, right? So how to calculate the mole fraction of the solute? Let us write the formula. Mole fraction of the solute. Mole fraction of the solute is equal to number of moles of solute number of moles of solute plus number of moles of solvent. Okay, so here see students, we know number of moles of solute, is it not 3 moles, but we do not know the number of moles of solvent. So how to calculate the number of moles of solvent? Number of moles of solvent can be calculated from its weight, that is W1 and molecular mass M1. Okay, so if you know the weight of the solvent and molecular mass of the solvent, it is possible to calculate the number of moles of the solvent. First we should know what is the solvent. See, from the problem itself we can understand it is aqueous. Aqueous means water. Okay, so the solvent is water, right? So what is the weight of water? See, from here itself it's given 1 kilogram of the solvent. So weight of the solvent is 1 kilogram. So if you are converting this to grams, then 1000 grams. Then we can calculate the molecular mass. Is it not? Molecular mass of water is 18. So molecular mass of water is, how to calculate molecular mass? From the atomic mass. Okay. So M1 is equal to 18. So now we can calculate the number of moles of the solvent. Okay. N1 is equal to W1 divided by M1. That's equal to 1000 divided by 18. So the value is 55. N1 is equal to 55.55. So now we can calculate the mole fraction of the solute. Is it not? Mole fraction of the solute, yeah, that is X is S is equal to number of moles of the solute. What is the number of moles of the solute? It is 3. Is it not? 3 divided by number of moles of the solute, 3 plus number of moles of the solvent, that is 55.55. That's equal to 0.051. So we have found out the mole fraction of the solute. Okay students, hope you might have understood. We'll see in the next session.